and welcome to Education at SSBJ online video tutorials. In this video tutorial, we are going to pick up a new chapter of Class 8 Science, chapter number 16, Light. We have already studied in class 7th about reflections. In this video tutorial, we shall see how light helps us to see things. You all know light is a form of energy. Like any other energy, for example, sound energy, heat energy, and so on. Light helps us to see the things. For example, if there is an object, let's say flower, which is there in front of your eyes, and when the light falls on the flower, you all know that it reflects. It reflects light in all directions. Some of the light which are reflected enters into our eye and then able to form a small inverted image right on the screen of the eye, which is called retina. Point to be noted here that it is a reflection of light which helps us to see the things. In this case, it is a reflection of light from flower. We see flower. Suppose, let's say it's dark and you have blocked the light. No reflections from flower and no image formation on retina. So first of all, it's the light which helps us to see the things, and objects are visible when they reflect light. You see all around you, things which can reflect light are all visible. In this case, a tiger when reflects light, it is visible to a person who is in front of him. So once again, light helps us to see the things, and objects are visible only they reflect light. But when light reflects, it follows certain rules. And those rules are formulated as law of reflection or laws of reflection. We shall have a demonstration to understand laws of reflection. Well, we shall understand laws of reflection with this demonstration. I have source of light here, and this will help us to get a beam of light. I also have a plane mirror because we have to direct a beam of light on this plane mirror. And to create a beam of light, I have got a small slit you can see here. And to focus a light, I have a lens here, convex lens. So what I do is, I am going to keep this here and then insert the slit here into this groove and then keep this base right in front of it. And we got a beam of light. And this beam of light reflects when it falls on the plane mirror. You can see that. Now please remember, the light which comes from the source is called incident ray. I repeat, incident ray. And where it has fallen right here on this point on the mirror. And that point is called point of incident. And then it reflects here. So this ray is called reflected ray. So once again, incident ray, point of incident, and then reflected ray, right? Now I want to measure angle. To measure angle, I have a protractor with me. But this is along with the plane mirror here, you can see. So I am keeping this one in place of the previous plane mirror right here. Now once again we'll recall. This light ray is called incident ray and this one is called reflected ray. It reflects, it bounces back, and the point here is a point of incident. And then this line which is drawn, which indicates a 0 degree, right? This is called as normal. Normal is anything which is drawn perpendicular to the plane. Let me repeat. Normal is a line which is drawn perpendicular to the plane of the mirror. Right? And now we can find out the angle on either side of this line. So if you can see here, this particular angle, which is between incident ray and normal, incident ray and normal, this angle is called angle of incidence. And the angle between reflected ray and normal is called angle of reflection. Now how much is that? Let me find out angle of incidence here. You can see here 20 degree is written here. So angle of incidence is 20 degree from here to here. Now look at the angle of reflection. Angle of reflection is also 20 degree. Now I am going to change the angle of incidence. You all know angle of incidence is the angle between normal and incident ray. And now you see angle of incidence from here to here is 40 degree, and you will find angle of reflection is also 40 degree. Which means as you change angle of incidence, angle of reflection also will change with the same magnitude. So what we can conclude here is angle of incidence is always equal to angle of reflection. This is important point. I'll repeat, angle of incidence is always equal to angle of reflection. The second point is, look at this incident ray and reflected ray. Also the normal. All three lie on the same plane. Right? This is important. Another second point it is. Now I am going to reduce this angle of incidence. What is the angle of incidence now? It is 20 degree and angle of reflection is also 20 degree. Now angle of incidence is 10 degree, reflection is also, angle of reflection is also 10 degree. Now if I take a incident ray right on the normal, the reflected ray goes back along the normal, and so angle of incidence and reflection both will become 0. Let us watch this animation. You can see here top view of the law of reflection diagram. Incident ray, reflected ray, as well as normal. Now, if you can turn around and go on a side view, you will find the reflected ray is slightly upward. It is not on the same plane. But what we have learned is incident ray, reflected ray and the normal requires to be on the same plane. That means this animation is wrong. Now, did you understand what do you mean by incident ray, normal and reflected ray are always lie on same plane? A red color platform represents a plane, and now you can see here incident ray, reflected ray and normal all lie on the same plane, and light behaves like this. So remember this. We shall conclude this video here, and in the next video we will learn how to draw this using your compass tools. Right? This is very important as far as your examination is concerned. Thank you.